All right, so before we get started on our explanation on what we're going to be doing tomorrow, that's Tuesday, I just want to say we spent some time talking about how to find the equation of lines from 2 points, how to find the equation of lines from a point and a slope. I would highly recommend that you spend a little of your time on Monday night, right now, to do a little bit of the algebra sheet so there wasn't as big of a frenzy Thursday or Friday when it is due. All right, so let's take a look at what we have for today. So we're going to be matching equations and tables for starts. And then we're going to go into the question of whether or not a line of best fit is a good measure of a set of data. And in particular, how good is that line of best fit to measure or to model the data that we have. So we're going to be looking at how to measure accuracy, and we're going to be talking about something called residuals. So we have an experiment, bridge thickness and breaking weight, just like we did. And we have a set of data. It looks very linear, although it's not perfectly linear. And we would be able to draw a line of best fit that goes through this data. Well, where would that line go? Well, if I were to take a straight line, how about a ruler? We'll pull up a ruler here. Math tools, ruler. I can see that a line that went right about here, it's not half bad. So that line's pretty close. Now, I mean, obviously I can take 0, 0 and link it with this problem here, or the top point here, draw another line. Now, which line is a closer representation of this data set? Well, I would say that the blue line is closer to more points than the red line. Because if you look at the red line, you have 2 points that are directly on it, one that's a little bit above, but then 3 that are just a bit below. Whereas the blue line is practically touching almost all except for one of those points. So, oh look, lines of best fit, perfect. So for question A, we have 2 lines of best fit. The blue line that I just drew, as well as figure 1. A figure 1, which is the red line that I drew. Well, which one's a little bit better? And this is a little bit clearer. You can see clearly that this is closer to more data points than figure 1. All right, well, I think we just did part A together. Oops. Make sure that's all written down, because that's important. All right. For question B, we're talking about residuals. Now, I'm not going to do this problem here, but a residual is looking at how far away the data is from the line that we are using to model this. So what we're going to be doing is you have the actual data here, but then the predicted model data is going to be the model of the data that we find using our line of best fit. Now there are 2 ways we can do this. We can use the graph and say, oh, 1 layer thickness at 10 pennies, 2 at 20. So we can use the graph for this data, but most of the time it's going to be easier to find the equation of our line of best fit. Once we find the equation of our line of best fit, then we can plug in our data for the number of layers, get the prediction, and then to find the residual, we'll take the actual minus the predicted, which means we could have a negative residual. So then we will calculate the residuals and see just how close we get to being a perfect line. Now obviously, if our line of best fit is perfect, we'll get a residual of 0, because every point will be on the line and the difference between each point and our line will be 0. All right, so that's what we're going to be looking at for the residual. For question C, oh look, we have the area that they're covering, how long it takes. We're going to plot the data, get a line of best fit, and then we're going to find the residual from our line of best fit. Now, everyone at home may have a different line of best fit, and that's okay. Everyone should be very, very close. So that is what we're going to be doing tomorrow. Please spend
15 to 25 minutes working on your algebra sheet tonight. See you tomorrow morning.